Welcome back to the second episode in our series on relational databases. In this episode, we're going to be talking about relations and relation states. So why don't we go ahead and make relation the mystery word for this episode. Now let's proceed. A domain is a set of atomic values. By atomic, we mean that each value in the domain is indivisible as far as the relational model is concerned. A common method of specifying a domain is to specify a data type from which the domain values forming the domain are drawn. It's also useful to specify a name for the domain to help in interpreting its values. For example, the domain states would be declared as a character string data type to represent a set of 50 states in an all-cap format. Or back to our academic example, the domain department codes, also using a character string data type, would represent a range including data values like BA, MGT, FIN, CIS, AC, and so on. So a domain is given a name, a data type, and a format. A relation schema, denoted by R, open paren, A1, A2, and so on, is made up of a relation name, such as student, and a list of attributes. Attribute is another one of those terms that refers to a column in a row discussed previously. Each attribute is the name of a characteristic displayed by some domain in the relation schema, such as the attributes ID, first name, last name, DOB, date of birth, and so on. A relation schema is used to describe a relation. What did we say in the previous lecture series that the term schema means? A description of a database, or in this case, a description of a relation. The degree or arity of a relation is the number of attributes in its relation schema. For example, if the relation departments in our academic database was made up of attributes department ID, department name, department chair, and school, then the relation departments would have a degree or arity of 4. A relation or relation state of the relation schema, that is the relation description, is a set of a number of tuples or records in physical terminology. You recall that the tuple refers to one of those rows in the database relation. Therefore, a relation state consists of all the rows in that relation, or all the rows in the table if you prefer. You may remember our discussion of database states from the previous lecture. Each group of tuples is an ordered list of a number of values where each value is an element of a domain of one of the attributes of that tuple, or it's a special null value. Null values represent attributes whose names are unknown or do not exist for some individual tuple. Now, in pure relational database theory, a relation has no order. This ordered list concept is applied when we are manipulating the database, generally speaking. We put the list in an order based upon one of those attributes. But in pure relational database terminology, there is no order to a relation. The terms relation intension for the schema and relation extension for a relation state are also commonly used. The intension is a combination of two things: a structure and a set of integrity constraints. The naming structure consists of the relation name plus the names of the attributes, each with its associated domain name. The integrity constraints can be subdivided into key constraints, referential constraints, and other constraints. The extension of a given relation is a set of tuples appearing in that relation at any given instance. The extension, therefore, varies with time. It changes when tuples are created, destroyed, and updated. We are going to discuss these constraints in great detail. So if you're not real clear about this right now, don't worry about it. You're going to get plenty of opportunity to learn more. Okay, let's take a break. Submit your mystery question. Go out to the Check My Knowledge section in the coursework area and check your knowledge. And when you're ready, come on back and we will proceed on to episode 3.